This is 4 examples of the sum and difference identities. So these identities, there are 6 formulas. There are 3 for the sum, 3 for the difference, and just be careful that as you're using them, you copy them very carefully. I find that the most common mistakes are people copying the formula wrong. So here we go. We are looking at sine of 75, and we want to find the exact value of that. So we're not using a calculator and putting this in and getting a decimal. We're finding the exact value. So in order to do that, we're going to change the number 75 into two numbers that can either be added or subtracted to make 75, but those numbers should come from your unit circle. So they should be something that you can find on your unit circle in any of the quadrants. You want to stay in quadrant 1 as much as possible because everything is positive in quadrant 1, and then you don't have to worry about plus and minus signs. So I need something that is 75 that adds or subtracts two numbers from the unit circle. So I decided to do 30 plus 45. 30 plus 45 is 75. And so I'm going to change the way it's written. Notice that that argument there, where the 75 is, it's called an argument. Notice that argument is still 75. So I haven't changed the value of this trig expression. I've just rewritten the argument to something equivalent. Now, the order doesn't matter. You could have written 45 plus 30. This is not the only two numbers that would have worked from your unit circle, but it was the first two I thought of. For example, you could have done 135 minus 60. Be careful if you're going into another quadrant, like 135. We'll do an example where that happens. But if you're going into another quadrant, now you have to be careful about all students take calculus and what is positive in which quadrant. So we really want to stay in quadrant 1 as much as possible. So this is using the A plus B formula. So up on the top, this is the formula that I'm going to use. I like to recopy the formula just onto my paper because I find that I make less mistakes when I do that. If I'm trying to like copy the formula and substitute in values, I find that I make more mistakes. So in this example, A is 30 and B is 45. So everywhere you see an A in the formula, change it into a 30. Everywhere where you see a B in the formula, change it to a 45. Now I'm going to substitute in values for each of these. So you know what sine of 30 is. Sine of 30, think of your unit circle, it's 1/2. So where you see sine of 30, that's going to disappear and you're going to put a 1/2. It was in quadrant 1, so positive. Cosine of 45. You should know that that's positive root 2 over 2. Cosine of 30, quadrant 1, root 3 over 2. Sine of 45 in quadrant 1, root 2 over 2. Once you get all those values in, we're just going to multiply and then add. Now, if you had done this problem 45 plus 30, the numerator would have been reversed. It would have been root 6 plus root 2, and that is perfectly fine. That's the same final answer. Let's try another one. Cosine of 255. So if you want, pause the video, see if you can come up with two numbers that add or subtract to make 255, but they come from your unit circle. So I chose to use 210 plus 45. Maybe you chose to do 225 plus 30. It will get us the same final answer. So now I'm using the cosine sum formula. And everywhere there was an A, I substituted in a 210. Everywhere there was a B, I substituted in a 45. So now here's where you have to be careful. 210 is in quadrant 3. So all students take calculus. Tangent is positive in quadrant 3. Cosine is negative. Sine is negative. So as I go to do cosine of 210, I have to ask myself, what's the reference angle, which is 30. And then I'm in quadrant 3, so it's negative. So cosine of 210 is negative root 3 over 2. Cosine of 45 is in quadrant 1. Great. Sine of 210, again, quadrant 3, that's negative. And then sine of 45, we're back to quadrant 1. Right? And now you'll multiply and kind of clean up your answer. Watch out for this double negative here. So this double negative will become a positive. And I changed my answer to make it root 2 minus root 6. If you have negative root 6 plus root 2 in the numerator, that is the same thing. Okay, so this problem we're dealing with tangent. If you look at tangent's formula, it's just a little bit more complicated because it involves a fraction. So we're going to have to simplify and maybe rationalize. So tangent of pi over 12, you can do this problem in radians if you'd like, or you can take pi over 12, convert it to degrees by multiplying by 180 over pi. And so this is tangent of 15. So I'm going to think of two numbers that add or subtract to make 15 that come from my unit circle. And a suggestion is when you're doing tangent, try to avoid using a number that is 30 or has a reference angle of 30, because tangent of 30 is root 3 over 3. And so you're going to, it's nicer to use tangent of 60 because that's root 3, or tangent of 45 because that's 1. So I'm choosing to do tangent of 60 minus 45. And when you do a subtraction problem, notice here my A value is 60. My B value is 45. It's not negative 45. The negative sign is the subtraction symbol. Could you do 60 plus negative 45 and then use the tangent sum identity? Yes, you could. But why would you want to leave quadrant 1? So this is my best option. 60 is in quadrant 1, 45 is in quadrant 1. So I'm going to, again, use that tangent difference identity. Everywhere there was an A, I put a 60. Everywhere there was a B, I put a 45. Tangent of 60 is root 3. Tangent of 45 is 1. So I'm putting those values into the formula. I'm going to simplify my denominator. And now I have to rationalize. I can't leave the radical in the denominator, so I'm going to multiply this fraction by the conjugate of the denominator on top and bottom. I'm allowed to do this because I'm multiplying by 1. And then I'm going to FOIL out the numerator, FOIL out and multiply out the denominator. And then at this point, I'm going to do sharing is caring. So I'm going to divide that negative 2 into the negative 4. And I'm going to divide the negative 2 into the 2 root 3. And so this is my final answer. Now, I want to show you this problem again quickly, but this time I'll show you what it looks like if you chose a 30-degree angle instead of 60 and 45, just to show you how it's a little bit more challenging. So if I had chosen to use 45 minus 30, perfectly fine. I would put those numbers into my formula, but tangent of 30 is root 3 over 3. So now I have this fraction within a fraction. So I have two things I have to deal with. I have to deal with the complex fraction, and I also have to deal with rationalizing the denominator. So step 1, I'm going to get rid of the complex fractions by multiplying the entire thing by 3 over 3. I'm allowed to do this because I'm multiplying by 1. And what it's going to do is get rid of those complex fractions for me. So I'll distribute the 3 to the numerator, and I'll distribute the 3 to the denominator. And then from here, I'm going to rationalize by multiplying by the conjugate. FOIL it all out, multiply it all out, simplify it, and you get the same final answer. So it just involves a little bit more work. So when you're dealing with tangent, again, tangent only, try to avoid using things with a reference angle of 30. It'll just make your work a little bit faster. All right, and we have, I think it's one last example. Yep. So this says simplify tangent of theta plus 3 pi. So first of all, you cannot distribute the tangent. This does not become tangent of theta plus tangent of 3 pi. Whenever you see two things being added or subtracted in that argument position, you're going to think sum and difference identities. So this is tangent of a plus b. So you're going to take that sum identity for tangent, and everywhere there's an a, you're going to replace it with a theta. Everywhere there's a b, you're going to replace it with a 3 pi. So there we go. And then I don't know what tangent of theta is. Theta just represents some sort of angle, which I don't know. But I do know what tangent of 3 pi is. So everywhere there's a tangent of 3 pi, I'm going to replace those values with whatever tangent of 3 pi is. So remember, tangent of 3 pi would be in the same location as pi. Its ordered pair is -1, 0. So tangent of 3 pi is y over x, which in this case is 0. So everywhere there's a tangent of 3 pi, I'm replacing it with a 0. And then I'm just multiplying and simplifying, and this simplifies to tangent theta. Most common mistake is, again, at the very beginning, people think they can distribute the tangent. And then, although in this example, if you distributed the tangent, it would get you tangent of theta plus tangent of 3 pi. That would get you to the correct final answer, but that is sheer luck and coincidence that worked out. That will not always be the case. And plus, I would not give you credit for showing your work properly. So again, most common mistake is for people to distribute the tangent. Don't do that. All right. I hope this was helpful, and have a great day.